Now that you know how atoms covalently bond, I'm going to teach you how to draw a Lewis structure. So you might be thinking, what the heck is a Lewis structure? Well, basically, a Lewis structure shows how atoms are connected and where valence electrons are in a molecule. And you might think, didn't we do that before? And yes, in class, we did draw out some examples before. We drew out some pretty simple ones. We drew out basically examples with, like a fluorine and a fluorine together, an oxygen and oxygen together. Okay, but oftentimes the molecules we're dealing with aren't just two of the same thing bonded together. And so there's like a system in place that can help us out with bigger molecules, with more complicated molecules, with molecules that don't just have two of the same element combined. And if you follow these steps every single time, you will get the right molecule. Okay, so there are 6 steps to drawing Lewis structures. I'm going to go through them all. You need these copied down. You will not get full score on your notes if you don't have them all copied down. There's a good chance you're going to need to pause the video to be able to catch up with me with your writing. Okay, pause when you need to. So step number 1 is you're going to count the total number of valence electrons in all atoms in that molecule. Step number 2, you're going to draw the molecule's skeleton and connect all atoms with single bonds. Step number 3, you are going to subtract the electrons you used to draw the skeleton from your total, and this is going to give you the number of valence electrons left to place. Step number 4, you're going to begin placing your electrons in pairs, starting with the most electronegative atom in the molecule. And then the goal is for all atoms to have an octet. Everybody wants 8 except for hydrogen, who wants 2, okay? Because the closest noble gas to hydrogen is helium, and helium is 2. So everybody wants octet of 8 except for hydrogen, which wants 2. Step number 5, once all electrons are placed, create double or triple bonds to satisfy any atoms that don't have their octet. And step number 6, count all valence electrons. This includes the pairs you placed and the bonds you made to make sure it matches your count from step number 1, okay? Once you have all those copied down, then unpause the video, and I'm going to step you through some examples. Okay, example number 1 is CH4, which is also known as methane. So if I'm following my steps, step number 1 is to count up my electrons. So here we go. Carbon is group 4, it has 4 valence electrons. Hydrogen is in group 1, it has 1, but there are 4 hydrogens, right? Because it's CH4, so 1 times 4 is 4. So my 4 plus my 4 is 8, so this molecule has 8 total valence electrons. Okay, that's step 1. Step 2 is to draw the skeleton. What does that mean? That means to draw the base of the molecule. And how are you supposed to know the base? Like, how are you supposed to know what goes where? The big hint is that the central molecule, the central atom, the atom that's in the middle, is the one that is listed first. And so what's the one that's listed first? Carbon. So that means that one's going to go in the middle. Okay? And I got 4 hydrogens, which means I'm going to place them on all 4 sides around carbon. Okay, so that is my skeleton. Okay, that's my step 2. Now, step 3, I'm going to connect them, each one with a bond. Okay, notice I drew in lines to represent those bonds. Next, I'm going to count up my electrons used. So remember, each bond stands for 2. So I use 2, 4, 6, 8 to bond them up. Okay, what was my original count? 8. What was this count? 8. 8 minus 8 is 0. I have 0 valence electrons left. Okay, well, let's check if everything's happy. Do I need to make any double bonds or triple bonds? Well, let's see. Carbon has 2, 4, 6, 8. It's happy. This hydrogen has 2. This hydrogen has 2. This hydrogen has 2. This hydrogen has 2. Remember, hydrogens are our exception. They're happy with 2. So everybody's happy. We've used all our electrons. We're good. That is our Lewis structure for methane. Okay, not too bad. Here's another example for you. PCl3, that's a Cl, not a Ci. Okay, PCl3. So that would be phosphorus trichloride. Step 1, counting up our electrons. Phosphorus is in group 5, it's going to have 5. Chlorine is in group 7, each chlorine is going to have 7, but in Cl3 there are 3 chlorines, so that's going to be 21. And 5 plus 21 is 26. So we have 26 total valence electrons available. Our next step is we're going to draw our skeleton. Remember that we are going to figure out what the central atom is. The central atom is the one listed first, so that means phosphorus is going to be our central, and we have 3 chlorines, so I'm going to put 3 chlorines on each side. Now let me tell you, I did top, left, right, but you could do bottom left, right. You could do top right, bottom. It doesn't matter where you put these chlorines, as long as if you think of phosphorus having like 4 sides, top, bottom, left, right. It doesn't matter which of the 4 sides you have, as long as you have 3 chlorines and each one is on a different side. Okay, so it doesn't matter at all. My next step is I'm going to connect those with bonds, okay? And then I'm going to count up my number of electrons used. 2, 4, 6. I've used 6. How many did I have before? 26. 26 minus 6 is 20. I have 20 valence electrons left to place. Okay, so now where do I start? If I go back to my steps, it says start with the most electronegative. You might be thinking, what the heck is that? Let's talk about it. Electronegativity is basically the tendency of an atom to attract electrons to itself. Okay, some electrons really like to go to certain atoms and they like to go to other atoms less. And so this is a really simple chart showing you that when you go from left to right, things get more electronegative. So things on the right side of the periodic table are more easily able to attract electrons than things on the left. And notice this arrow, things at the top are more easily able to attract than things on the bottom. Okay, so based off of this, right, like this is going to be our high point and like this would be a low point, right? Okay, so going back to it then, remember we're doing P and Cl, so let's look which one's going to be more electronegative, P or Cl. Well, going left to right, Cl is further right. Going top to bottom, they're both like in the same row. So they're both the same like vertically, but horizontally, chlorine is more to the right. So chlorine is going to be more electronegative. So we're going to start placing electrons in pairs with the chlorine. Okay. Now again, just like how I said, it didn't matter like exactly where your chlorines went. It doesn't matter which chlorine you start with. I started with the left chlorine. You could start with top, right, whatever. It doesn't matter where you start. I just randomly picked that one to start with. Okay, so there we go. Remember, I've got 20 left, so I'm going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, and then the only body that's left is phosphorus, 20. Awesome. So I've placed all 20. Now I'm going to do my check to see if the octet rule has been fulfilled for everybody. So this chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. 2, 4, 6, 8. Phosphorus has 2, 4, 6, 8. Great. Everybody's octet rule has been filled. And just as one final check, let's make sure I didn't accidentally place too many electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Hooray. I'm where I should be. All right, let's do one more example. SO2. Let's count my electrons. S has 6. Each oxygen has 6, but since there's 2 oxygens with the O2, 6 times 2 is 12. 6 plus 12 is 18. So I've got 18 valence electrons. Next, I'm going to draw my skeleton. Central atom comes first, so S is going to be in the center. And I've got 2 oxygens. Again, I picked left and right. As for right now, it doesn't really matter where they go. You could have done top and bottom. You could have done top and right, whatever. For right now, it doesn't really matter where they go. Later on, you'll kind of learn more about that. But for right now, it doesn't really matter where you put your 2 oxygens. Next, I'm going to connect with single bonds. And let's count how many atoms were used, or how many electrons were used. We had 2, 4 electrons used. What was our initial count again? It was 18, okay? So 18 minus 4 is 14. We have 14 left to place. Again, where do we start? We start with the most electronegative thing. So let's take a look again at our chart and compare oxygen and sulfur. Which one's more electronegative? Which one is further in the upper right-hand corner? Look, there's oxygen. It's just one above sulfur. So oxygen's more electronegative, so I'm going to start with oxygen. Similar to last time, it doesn't matter which oxygen I start with. I just happen to pick that one, but it doesn't matter. So I'm going to keep counting by 2s until I reach my number of 14. Remember, I had 14 left to place. 2, 4, 6, 8, 10, 12, 14, right? I've got 2 left. Again, it doesn't matter if they go on top or the bottom of the sulfur, but I've got to 14. I can't put another 2 down here because that would be 16, and I only had 14 left, so I've got to stop there. So I'm all out of valence electrons, and now I'm going to see, are there octets fulfilled? Let's check oxygen. 2, 4, 6, 8. Yep, this oxygen 2, 4, 6, 8. It's good. Sulfur's got 2, 4, 6. Oh, uh-oh. Okay, sulfur's not happy. It's short a pair. So what's it's going to do? Remember, what did we do before? We're going to need to make a double bond or triple bond, right? But it's only short 2, so that's going to mean we just need one more bond. We're going to need to make a double bond. You're going to pick an oxygen. It doesn't matter which one you pick, and we're going to take a pair of those oxygen electrons and make a double bond out of it, okay? So I just randomly picked the right one. And so I erased them from below, see how they were below before. And it doesn't matter which pair of oxygens you pick. I could have picked the left or the top or whatever. It doesn't matter which one of these 6 you pick. I picked one pair, I erased them, and then I drew a double bond in between. And now let's check. Okay, we got 2, 4, 6, 8. 2, 4, this bond is 6, this other bond is 8. And now let's check sulfur. 2, 4, this bond is 6, this bond is 8. Okay, so now its octet rule has been fulfilled. So that's how you draw Lewis structures. If you follow those 6 steps every single time, it should get you to the right place. And we are going to spend like a whole day drawing them tomorrow. We're going to spend a day building some things. So you're going to get a bunch of practice with this in class altogether.